Let's take a look. First question says, in the diagram, PR is a diameter of the circle with center O. Okay, before we go any further, if PR is a diameter, we know that that diameter subtends a 90-degree angle in the circumference. You should know that immediately. Then it says that ST is a tangent to the circle at T. Okay, guys. Also, tangents, very important. Angle between the tangent and a chord is equal to the angle subtended by that chord on the circumference. Very, very important. Lastly, it says that that tangent meets RP produced at S, so they've extended that diameter to meet the tangent, and they've given us that angle SPT is X and angle S is Y, which is labeled on our diagram. So there is only one question to this rider. It says, determine with reasons the size of angle Y in terms of X. Okay, guys, when you get a question like this, if it says in terms of X, the only variable you can have in representing that Y value is X. You can have numbers and things complicating it. I could have 3x minus 270 degrees. That's fine as long as the only unknown in that expression is X. That's what that in terms of X means, okay? Can be X plus a whole bunch of different degrees, divided by degrees, multiplied by degrees, but only one variable, X. Okay, so let's have a look at this. If I look, I'm trying to express angle Y in terms of X, okay? So I'm definitely going to be making use of sum of angles in a triangle. So let's first start with our triangle inside the circle. I hope you guys agree with me that I can say angle PTR is equal to 90 degrees, which is what we identified at the beginning. And the reason is angle in a semicircle. Okay, that's maths language for the diameter subtends that angle. So we've established this 90 degrees over here. So now, to get from this triangle into the one in the circle, we can use exterior angle of a triangle. But if we want to do that, we need to find out this angle R over here. So, therefore, angle R is equal to, well, if we take a look, okay, if we look at this triangle here, our triangle inside the circle, if we extend that side, we get our exterior angle, which is X. So we know that X is equal to angle PTR, our right angle, plus angle R, because of exterior angle of a triangle. Okay, so if we manipulate to find R, we know that angle R is equal to, this PTR is 90 degrees, so it is X minus 90 degrees. So remember to write that out in your reasoning. Angle R is equal to X minus 90 degrees, and that came from exterior angle of a triangle. Okay, so we have that this angle here is 90 degrees, or X minus 90. Make sure I write it in the right order. X minus 90 degrees. Okay, so now if we start moving into our big triangle, that whole triangle STR, we know that angle STP, which is that angle between the tangent and the chord, is equal to angle R. Why? Tan chord theorem. Okay, so now we've established, we've got X minus 90 over here, X minus 90 over here at R, which means in our big triangle, okay, remember we've got Y over here, we've got R over here, which is X minus 90, and then we have two angles happening at this vertex T. If I add them together, I've got X minus 90 plus 90, so this whole angle here is equal to X. Okay, so if we go and look, therefore X plus X, well not even X, the first one is Y, sorry for that. This angle here, Y plus X minus 90 degrees is equal to 180 degrees. And the reason is sum of angles in a triangle. Okay, So now if we simplify, y plus 2x minus 90 degrees, remember, if I take this positive and I distribute it into the bracket, a positive times a negative is a negative. Okay. So minus 90 degrees is equal to 180 degrees, and that all came from our interior angles of a triangle. So now, if we further manipulate, y is equal to 180 degrees minus 2x, and if I add 90 degrees to both sides, I get plus 90 on that side, which means that y is equal to 270 degrees minus 2x. Okay. If you come and have a look over here, we basically identified that we need that angle there, okay? And then if we wanted to work immediately, let me get rid of this whole mess. If we wanted to work immediately in this little triangle here to establish a relationship, that's fine, but we know nothing about this angle over here. So that is why we had to go and translate into the bigger triangle on the circle and use that tan chord theorem. Remember always that a diameter will subtend 90 degrees on the circumference. So guys, when you get a question like this, if you have more than one triangle and the variables that you need appear in one triangle and you're missing something, try to start in the other triangle where you have information. We're going to test your geometry theorems here. This is where we test whether you've understood and how to apply those theorems. Okay, so my suggestion, even with similarity, if you're trying to find a side of one triangle and it has another triangle in common, start with that triangle. More often than not, you need to work your way into the triangle that involves the side you're trying to find. Okay.